So hello everyone, welcome to my talk, binary log servers, the missing MySQL infrastructure component. As Shlomi already mentioned, we have kind of conflict between our content, but I will not think so. It's kind of, we are trying to solve the same problem, but probably from a bit different perspective, or concentrate on other part of those problems. So I hope you will enjoy it as well. My name is Yura. I am a software engineer at Percona, and as you can see here, a big fan of MySQL and C++. This is a photo of me, of 10 years old probably. Look how happy I am, still smiling. It was before I joined Percona. Yeah. So I do not have enough time. It's a 25-minute talk. I will briefly describe a few examples. Shlomi probably mentioned some of them, but this is what we saw from our customers' operations and problems they were trying to solve. So let me just show them here. Basically, continuous bin log backup for point-in-time recovery. Very primitive scenario. Even we saw people even using not just MySQL-D as a way to collect bin log events, but just MySQL bin log utility, which they were running in a loop, having some additional scripting for interruptions. It wasn't perfect. It was working mostly on probably on file level. Sometimes it was possible to continue operations from the middle, but it was again a lot of manual work there. But in general, running the utility, not being able to reconnect, and manual upload to a cloud storage when you need more persistent storage, I would say. Another example, something similar. Jean-Francois probably was doing, and after us talking internally, we found a lot of similarities, but I wanted to emphasize on a bit different problem here. Some people were doing, using MySQL-D as just a way of propagating bin log events to other parts of the topology, and for that they use an interesting trick with creating identical schema on here level 0 replicas, but switching actual storage engine from InnoDB to black hole, so that we want any data won't be written permanently. We will just this operation will be as fast as possible as MySQL-D allows, and we will have another set of binary logs written, and they could be served to the level 1 replicas as well. A little problem here that when events pass through this level 0 replicas, which some people call binary log servers, we lost some important information required for parallel applier. So after that, level 1, after passing through level 0, level 1 replicas will all be able to apply events single-threaded. There are a few pretty old bugs connected with this. One reported upstream, one from Percona, and it's 7.5 years old. Still no solution yet. What it means for Percona? We saw an opportunity. There are at least two scenarios. primitively described by me at this point, for which we think we can do better. And we saw an opportunity for creating a new project which would be dedicated exactly to solving those problems. So it's now a real thing. It's an open source product called Percona binary log server. It is available on GitHub already, maybe for quite some time. It's under a GPL2 license. It's written in C++ with best practices of clang tidy checks, clang formatting, continuous integration, unit tests, and surprisingly, we also managed to integrate MTR, MySQL test run infrastructure for integration testing. So it's for spawning an instance of MySQL, running our binlog server, grabbing some data and analyzing it. It was a perfect match for our needs. Just a proof link that it's true, a screenshot from GitHub. Now let me talk probably about what we currently have implemented already. At this stage, I wouldn't say that we advanced as far as Shlomi, but at this point I would call our product MySQL binlog utility on steroids. This is just a quote from readme.md file from GitHub project. It's a command line utility that can be considered as an enhanced version of MySQL-D run in read from remote server mode, which serves as a replication client and can stream binary log events from remote Oracle MySQL or Percona server for MySQL. Blah, blah, blah. It is capable of automatically reconnecting to remote server and resume operations from the point when it was previously stopped or terminated. And let me go in details through some of the key features we have here, and I will try to compare with other approaches to solve similar problems. In comparison to just having a dedicated instance for collecting bin logs, we do a bit better job because we don't have an overhead of full-blown RDBMS. We operate on a binary log events level. We know nothing about transactions. Okay, sorry. We know about transactions, but we do not know about database internals and do not need to create actual views of the data. We just operate on bin logs. In comparison to MySQL binlog utility, we support continuous pooling mode, and most importantly, we are able to reconnect and resume from previous state. One more important thing, we natively from the very beginning support working with cloud storages like S3. We started with AWS S3 implementation, native one, but very soon we realized that a lot of people ask for S3 compatible storages like min.io, where we could specify custom endpoint basically. We added support for that, and in general it's a pretty pluggable architecture, so it's one day we want to add Google Cloud or Azure, for instance, we will be able to do this. Currently, binlog server operates in two modes, which I call fetch and pull here. One is mostly for testing purposes, just shoot, grab everything you can and terminate, and another one is continuous, one called pull, where you can run this process in the background and it will continuously do all operations you want. Basically, I've just described with trying to connect, continue from previous position, if error occurred, doing some pause, and trying to reconnect again. In addition to that, we had a few requests from our operators team, primary requesters currently of this project, for their point-in-time recovery needs. And in particular, what they wanted us to do was to answer two simple questions for them. They want, for instance, do a point-in-time recovery up to a certain timestamp, and what we need to provide them, a minimal set of binary log files stored in the cloud, which are necessary to restore to this certain point of time. Or similar task, provided that we have a GTAD set, we need give me the minimal set of files which would cover this GTAD. We can do this now, and let me now describe a little how this could be done from the user point perspective. Winlog server is currently just an utility with one configuration file in JSON format with several sections. Here I will go through them and alongside describe what we can do and what can be configured. So let's start with connection section. Basically, here we describe the source of replication. We support 8.0 and 849X protocols. I kind of made them separate because there was little change. One new event was introduced in 8.3, I believe. It was called tagged GTADs, and it affected logic a little bit. We support full variety of SSL options, as you probably all expect. With no doubt we did this. We also support DNS SRV name connections. A kind of important thing for Kubernetes environment when the host to which we want to connect can be identified via DNS records and some configurable read connection, write timeouts. Replication section. Another section in this JSON configuration file. Here we can specify in which mode we are going to do replication. It's actually an interesting story. We started from position-based replication only here, but for the proof of concept, because for obvious reasons it was easier to do at initial stages. But after that we had a few talks with Jean-Francois, and he convinced us that even in modern world, where everything is GTAD, having, for this particular scenario, having position-based replication and producing physical identical copies of binary log files from a server can also be a pretty useful instrument. But nevertheless, we support GTAD-based replication as well, where collected files may not be physically identical, but they will include all the required, all the transactions from different sources. We support checksumming and specifying server ID, just a requirement for replication protocol. As for the storage, again, started as with local file system for simplicity reasons. We had only a few ideas to support clouds in future, but it turned out it might also be useful for some scenarios. And so currently we have support for storing the logs locally and storing them directly to S3 or S3 compatible storage. We do for cloud, we do a few interesting things which we called checkpointing. So we do not immediately flush data to disk, to local disk or to S3. We kind of buffer this operation and can specify two types of events on which flushing real write could happen. And this is one of them is size-based. As soon as our internal buffer reached, I don't know, 128 megabytes, do the flushing, or do the flushing every 30 seconds, or whatever comes to your mind. So how to use it? Just create a simple configuration file. Put this three sections I just described, plus one section for logging I omitted here for simplicity reasons, and run the utility. Binlog server pull JSON config, and very soon you will see something like this. A few files, you must be familiar with binlog index and regular binary log files, but there are certain metadata. Shlomi had something very similar on his slide, but probably put it in a bit different format. We put some metadata in JSON files associated with each of the binlog files here. Now let me talk about a few problems that we it sounds simple, but it wasn't really easy to implement. So it's a few discrepancies between 8.0 and 9.4 servers with this new GTAD tagged log event. Kinda not the hardest problem, but still we have to take into account this. Then initial sequence of event we receive from binary log from the MySQL server upon connection, artificial rotate event, format description event, and optional previous GTAD logs event. Sometimes they're purely virtual for information purposes. Sometimes they need to be written to permanently to data files. One of the important things, as I should probably have put in features as well, is we are aware of transaction boundaries in binlog files. So we try to keep binlogs in state where the data written there is never in the middle of transaction. So we had to do some additional transaction parsing, and for that, luckily it was much harder. Luckily in 8.0 it's much easier than it was in 5.7 because GTAD log events now have information about size of the upcoming transaction. It was a great helper for us. And yeah, as I already said, we try to write data only at transaction boundaries. It helps with recovery, with resuming operation, and especially in GTAD mode. Reconnection logic with simple goal to minimize open-close operations for our storage. Because even to initialize operation on S3, you need at least read the content of S3 bucket virtual path, do some analysis of files there, probably read metadata. It's not a simple operation. So if we just disconnected from MySQL server and reconnected, it may not be a good thing to start from the beginning. So we kind of reused optimize this logic to minimize open-close operations for the storage. We also, in those JSON files I just showed on previous slide, we keep track of GTAD sets associated with each binlog file. It helps a lot with those search tasks I mentioned for our operators team for searching files for certain GTAD sets. And those files also include minimal and maximum timestamp of binary logs events in them. This helps with time-based search. For GTAD mode, similar to what Shlomi showed us, we do some renaming of binlog files just for a simple scenario when we were working with one server in the topology, then it went down and we reconnected to another one. There is no guarantee that on those servers binary log files were physically identical. So they could be rotating data at different points. So there is no such thing as relying on rotate events and extracting file names. From there, we had to keep our own naming conventions there. And one of the challenging tasks was also implementing the append operation for S3, which natively just doesn't exist, but there is a trick with multi-part upload there, which we kind of have it as an experimental support at the moment. Now, this is what we have, but I will also want to tell you where we are going. Although we haven't implemented as much as Shlomi did, we can promise you that our product is actively developed at the moment, and we will continue investing in it. So please, if you're interested, put us like on GitHub project, so I will see who is interested in it. But I'm also share with you our plans for what we are going to do next, or at least planning to do this. I would start with supporting multi-tenant and some control interface for this. What I showed you was just a single client, probably alternative to MySQL binlog utility, but what if you want to have a single instance of this binlog server which would collect data from different sources, store them in different places, being like a centralized grabbing utility in your environment or in part of your environment. Here, a few ideas how we can do this with possible primitive syntax, creating storages, creating servers, starting replication, etc. Also, at some point, maybe people would like to see this control interface as a REST one. Web guys would like this. And most importantly making binlog server a server. which would be able to serve as a replication source for your topology. Shlomi did this. We still haven't got to this point, but we are definitely planning, and this will help us basically to build all the complex topologies I showed on previous slides, and Shlomi showed on his with chaining Winlog servers, with Winlog servers used just for backup purposes, GTAD-based mode, position-based mode, whatever you like. And probably I'm almost on time. Yeah. Thank you very much.